This is section 1.2, Graphs of Equations. Our learning goal for this section is to sketch graphs and use them to solve real-life problems. And more specifically, the three things we're going to be doing to achieve this is first, determining if given points are solutions to an equation. Next, we're going to sketch graphs of equations. And for our third objective, we're going to find the x and y intercepts of graphs. So the first thing we're going to explore is how to determine solutions to an equation. And that begs the question, what is a solution to an equation? So let's briefly talk about what a solution is. And as you can see, the math definition of a solution is a value or a point that makes the equation true when substituted into the equation. And all that means, as we're about to see, is that we're going to plug in x and y values into an equation to see if it produces a true statement. So as you can see here, I'm giving you the equation y is equal to 8x minus 5. And for parts A, B, and C, what we have to do is plug in the given point to see if it produces a true statement. So let's go ahead and start with part A. Here I'm given the point 1, 3. And remember that when we have an ordered pair, the first number is always the x value and the second number is always the y value. So what we're going to do is we're going to go ahead and substitute these x and y values into our equation. So instead of y is equal to 8x minus 5, we're going to have 3 is equal to 8 times 1 minus 5. And if we go one extra step and simplify this a bit, we know 8 times 1 is just 8 minus 5. And we end up with 3 is equal to 3. And so remember, when we plug in values, we're trying to figure out if this thing is true, as our definition says, and 3 is equal to 3, in fact. So this is a true statement, which means that the point 1, 3 is in fact a solution to our equation, y is equal to 8x minus 5. So if we move on to part B, again, negative 2 is our x, 4 is our y, and when we plug into our equation y is equal to 8x minus 5, we're going to have 4 is equal to 8 times negative 2 minus 5. And when we simplify this, we have 4 is equal to negative 16 minus 5. And at this point, you might realize that this will not be a true statement because 4 is equal to negative 21 is actually not true. And so in this case, we would say that the point negative 2, 4 is not a solution to our equation. And for part C, once again, 4 is our x, negative 3 is our y. So when we substitute into our equation, we have negative 3 is equal to 8 times 4 minus 5. And if we simplify this out, we get negative 3 is equal to 32 minus 5, which simplifies to 27, which in this case our statement now says negative 3 is equal to 27. That's clearly false. And so we can conclude that the point 4, negative 3 is not a solution to our equation. Now for this next example, we have a quadratic equation, y is equal to x squared plus 2x plus 1, but the idea is still the same. We're going to take our x and our y value and plug them in anywhere you see an x or a y in the equation. So when we do that, we should get 7 is equal to 1 squared plus 2 times 1 plus 1. And when we simplify this out, we should just get 1 plus 2 plus 1, which just comes down to 7 is equal to 4, which is in fact, again, false, and therefore the point 1, 7 is not a solution to the equation. And when we check part B and we plug this in, we have 9 is equal to 2 squared plus 2 times 2 plus 1. And when we simplify this out, 2 squared is 4 plus 2 times 2 is 4 plus 1. We end up with 9 equal to 9. In this case, it is a true statement, and so the point 29 is in fact a solution. So shifting gears, the next thing we're going to do is graph equations. Now, there's basically three ways we're going to be graphing equations. The first one, in previous classes, you may have used certain patterns or otherwise thought of as shortcuts to graphing certain equations, such as mx plus b is an example of this, or you may have used some sort of pattern to graph parabolas. But if it's the case that you don't know one of these patterns or shortcuts, then we could always resort to strategy number 2, which is creating a table of values. As you'll see in just a little bit, we'll do this by creating a little table with x and y values that will give us points, which then we can go and plot to get an idea of what our graph looks like. And then the last alternative is use of technology. However, I will ask you guys to make some graphs without the use of technology. So the first example we're going to look at is the equation y is equal to negative 3x plus 2. For this one, I'm going to go ahead and use one of those patterns that we were talking about. And specifically, I'm going to be using y is equal to mx plus b to help me graph this equation. If you recall using this in your algebra classes, we always start out with this b value, which is the y-intercept, which in this case is 2. So that means on our y-axis, I'm going to go ahead and place a point at 0, 2. And the next thing we're going to look at is this m value, which in this case is negative 3. That represents our slope. And if you recall, slope is just your change in y over your change in x. So that tells you how much you have to go up or down, as well as how much you're going to go left or right. And again, on this problem, we're given a slope of negative 3, which is represented as a whole number. But to help me visualize the y component and the x component a little bit better, I'm going to go ahead and rewrite that as negative 3 over 1. And so now that I have a fraction, negative 3 over 1, that is my rise over my run. And so I can go ahead and find my next point using that. So starting at the point that we already plotted, I'm going to go down 3 spaces because I have a negative 3 for my y. Then I'm going to go over 1 space since I have a 1 for my change in x. And that way I find another point in my line. Likewise, from that point I just plotted, I can go down another 3 and then over 1 more. And at this point you can kind of start to see what the graph of the equation is looking like. So there is our graph for the equation y is equal to negative 3x plus 2. For this second example, I'm going to use a different approach, so I'm going to make a table of values to find some points of this equation in order to graph it. And just know that going forward, you are welcome to use whichever of the two methods you prefer for graphing equations by hand, whether it is using a shortcut or using a table of values as you're about to see. So again, for this example of y is equal to 1 minus x, we're going to draw a table of values, find some points, and then draw our graph using those points that we obtained from the table. So if you recall, x is the independent values, so you can basically choose any x values you want here. Just to stay around the center of our graph, I'm going to go ahead and choose the values of negative 2, negative 1, 0, 1, and 2. So now, in order to get our y values, we just have to take these x values that we chose and plug them into our equation, y is equal to 1 minus x. So if I look at my first x value, I would have y is equal to 1 minus negative 2. And anytime you're subtracting a negative, it just becomes a positive, so y is actually equal to 3. Then if I go down, we're going to plug in x is equal to negative 1, so I'm going to have 1 minus negative 1. And the same thing, we would have y is equal to 2. Likewise, for x is equal to 0, we have 1 minus 0, so that means y is 1. Then if I plug in 1, I have 1 minus 1, so we get a y value of 0. And then finally, I have 1 minus 2, so we get negative 1. And now each one of the rows in our table of values represents an ordered pair, so we can go ahead and graph that. So negative 2, 3, I'm going back 2 and up 3. Then negative 1, 2, I'm going back 1, up 2. 0, 1 would be here. 1, 0 would be here. And then over 2 and down 1. And then again, we can just draw in our line and we are done. So now we have a quadratic equation example, and for this one, I'm also going to go ahead and use a table of values. And then once again, you can choose basically any x values you want, but usually good options are negative 2, negative 1, 0, 1, and 2. And we're going to use these x values to plug them into our equation and figure out what the corresponding y values are. So for my first x value, I have -2. So I'm going to go ahead and replace all the x's with a -2 and simplify this out. -2 squared is just 4, plus 2 times -2 is -4, plus 1. So our 4 and our -4 cancel out, and we're just left with a y value of 1. Likewise, for x is equal to -1, I'm going to plug that in and simplify that out. -1 squared is 1. 2 times -1 is -2. And then plus 1. Here I have 1 minus 2 plus 1. So we're going to end up with a value of 0. I'm going to continue to do the same thing for each of the other points in our graph. I'm going to get a 1 for our x is equal to 0 value. I would get a 4 when we plug in x is equal to 1. And then finally, we would get 9 when we plug in 2. And once again, we can take each one of these ordered pairs and graph them. So -2, 1 would be somewhere around here. -1, 0 would be here. 0, 1 would be here. 1 and then up 4. And 2, 9 would be all the way up here. So our graph is going to look something like this, and it also helps to remember that quadratic equations create parabolas which are always symmetrical. So the last thing we got to talk about in this section is identifying intercepts of a graph. The intercepts of a graph are just the points where the graph crosses or touches either the x or the y axes. And to find these intercepts, we have to check each one of the axes. So in order to find the x-intercept, we have to set y equal to 0, then solve for the x variable, for the x value. Likewise, if we want to find the y-intercept, we're going to set the x equal to 0 and then solve for the y value. So in short, if you're going to find the x-intercept, you're going to set y equal to 0, and if you're going to look for the y-intercept, you're going to set x is equal to 0. So for this first example, let's go ahead and practice finding the x and y intercepts of the equation y is equal to 2x minus 4. I'll go ahead and start with finding the x-intercept. Remember, when we're finding the x-intercept, we're going to set y equal to 0, so I'm replacing the y with a 0 in our equation. Then I have to solve for x, so that means I have to get at the x by itself. So I'm going to go ahead and add 4 to the other side. So I have 4 is equal to 2x. And when I divide 2, I have x is equal to 2. So my x-intercept, where this graph crosses the x-axis, is at x is equal to 2. And we can write this out as an ordered pair. So if we're crossing the axis when x is equal to 2, then we're talking about the ordered pair 2, 0. And we're going to follow a similar process when we're finding the y-intercept. The big difference is that when I'm looking for the y-intercept, I'm going to set the x value equal to 0. So I'm going to keep y the way it is, and we're going to have 2 times 0 minus 4. And if I simplify this out, 2 times 0 is just 0, so I'm left with y is equal to -4. And that means our graph is crossing the y-axis at y is equal to -4. So the point corresponding to that is just 0, -4. So we have now found both of our intercepts. For our x-intercept, we have the point 2, 0, and for our y-intercept, we intercept the axis at 0, -4. So for this last example, we're going to try to find the x and y intercepts for the equation y is equal to x squared minus 4. So if we begin with our x-intercept, remember we got to set y equal to 0. That's how this always works. So if we substitute 0 for y, we're going to have 0 is x squared minus 4. Our next task is to isolate the x, so I'm going to go ahead and add the 4 over to the other side. So I have 4 is equal to x squared. And the last step, in order to get rid of the square with the x, we're going to have to square root both sides. Here you have to be really careful, because if you recall, anytime you take the square root of a number, you're going to get a positive and a negative result. So in this case, the square root of 4 is actually positive and negative 2. So we actually have two x-intercepts for this equation. The first one crosses the x-axis at negative 2, 0, and the other one crosses at positive 2, 0. So let's go ahead and find the y-intercept now. And anytime we're looking for the y-intercept, remember we're going to set x equal to 0. And so on our equation, we're going to have y is equal to 0 squared minus 4, or just y is equal to negative 4. And so our y-intercept is the point 0, negative 4. And so finally, if we quickly just take a glance at the graph of x squared minus 4, we can in fact see that it does have two x-intercepts at negative 2, 0 and positive 2, 0, and it has one y-intercept at 0, negative 4.